In this video, we're going to talk about how to calculate formal charge. So let's say we have an example of a carbon bonded to two hydrogens, double bonded to a fluorine, which has, actually let me draw the fluorine red, which has two lone pairs. So each of these is a lone pair. What is the formal charge around the fluorine? In order to calculate this, we need to use an equation, which I've pasted in. So the formal charge equals the number of valence electrons that the element would have in its neutral state minus the number of bonds and dots that it has in this particular structure. So how do we figure out how many valence electrons fluorine has in its neutral state? If you look at the periodic table and look at the group which fluorine is in, you can see that on the top it has 7A. So fluorine is in group 7A. So therefore it has 7 valence electrons. In this structure it has 2 bonds and it has 4 dots. Notice that we're counting the number of dots or number of electrons, these blue dots, not the number of pairs. If you were to count the number of pairs, you'd have 2, but you're counting the number of dots, so you have 4. So 2 plus 4 is 6, so you get 7 minus 6, and that's going to be 1. So since this is a positive number, it means that this atom is going to be positively charged. So you're going to have a +1 charge on the fluorine. Now let's go over a few more examples. Let's say we have a carbon which has 3 bonds to something and it has a lone pair. What is the formal charge of this carbon? Our equation for formal charge was valence electrons minus bonds and dots. If you look at carbon on the periodic table, it is part of group 4A. So it's going to have 4 valence electrons in its neutral state. In this structure, it has 1, 2, 3 dots, or actually, 3 bonds, sorry. It has 3 bonds, and it has 1, 2, 2 dots. So 3 plus 2 is 5, and so the formal charge of this carbon is going to be -1. So you can put a negative around the carbon. It's going to be a carboanion. In the next example, let's look at ammonium. Ammonium is a nitrogen that has 4 hydrogens attached to it. Go ahead and figure out the formal charge of nitrogen. Feel free to pause the video. When you look at the periodic table, nitrogen is in group 5A, meaning that it is going to have 5 valence electrons. In this structure, it has 1, 2, 3, 4 bonds. And it is not going to have any lone pairs, so it has 0 dots. And 5 minus 4 is 1. So this particular nitrogen is a cation. It has a +1 charge. In the last example, let's go over an example of an oxygen. In this situation, we have an oxygen which is bonded to a carbon, and it has it has 3 lone pairs, so it has 6 dots. In order to calculate the formal charge, we need to figure out how many valence electrons it has. Oxygen is part of group 6A on the periodic table, so it's going to have 6 valence electrons, and it has 1 bond, and it has 1, 2, 3, 4, 5, 6 dots. Should have wrote 6. 1 plus 6 is 7, so the oxygen has a -1 charge, so you can put the little negative around it to denote that. Quick note as we leave here, or end the video, I'm going to draw the most commonly used elements in organic chemistry. And I'm going to have the groups that they are members of. So carbon is always going to have 4 valence electrons. Nitrogen is always going to have 5 in its neutral state. Oxygen and sulfur are going to have 6. And then the halogens, which are in group 7A, are going to have 7 valence electrons. So in case you didn't remember that, you can memorize those. It'll be useful in doing problems like this, so you don't have to look back at your periodic table every single time. Thank you for watching this video, and that's all I have.